Because we are live, we can start.
Okay, thanks, Sukanya. So I request the experts to switch on the camera. So because we are live now. Okay, thank you. So good morning to people coming from Ghana. Good evening to people from the East, and good afternoon to people from India. We welcome you all to this very interesting session on why cities are getting submerged. So, why cities are getting submerged? There are different theories. There are people talking about different reasons why cities are getting submerged very frequently. And we have an excellent panel to talk about this and discuss about the different issues of urban flooding, right from the climate change in the rainfall pattern, the gaps in the urban planning, and obviously the solution way ahead. So I will start my session with just unfolding the session. I have the presentation. I do not have a very structured presentation. I would like to give the experts to talk about this because they have a big experience years for them are big, like, so they can actually talk about all their experience, talk about their learnings, talk about the research they have done throughout the years. So I start with unfolding the sessions. So here, as I told you that the topic of this session is why do cities get submerged and why urban flooding has become a very frequent, event in the cities. So what is it? Is it the changing rainfall pattern? Is it that there are reduced number of rainfall, number of rainy days, changing increased intensity of rainfall coming in a very short period of time, or is it human induced factors? Like often, Delhi, cities like Delhi, Mumbai, Chennai, Bengaluru, they are hitting the headlines for all wrong reasons because of urban flooding. So one is cities like Delhi and Mumbai, they are depending on the colonial era of stormwater drains. They are not well designed. As for example, if you take the example of Mumbai, it has been designed to hold 25 millimeter per hour. Now the city is experiencing 100, almost 4 times more intense rainfall. So how will the stormwater drains cater to that? So what is the solution for that? And also we have the clogged stormwater drains. Then another example is the city of Bengaluru, which was once known as the city of lakes, which had series of lakes connected through natural channels. And now what is happening? The lakes are built over, the interconnecting channels are also encroached, so the natural channels are also not there. So what is happening is, like, big cities like not only Mumbai, Delhi, Chennai, Bengaluru, but smaller ones like Nashik, Gwalior, they are also experiencing urban flooding. One is the changing pattern of rainfall. Another, we have seen that there are flaws in the urban planning system. And number three, we are seeing that the stormwater drains are not well designed. And over and above this, the sponges in the city are encroached. The latest Rajya Sabha question of December 2024 shows that almost 3,000 crores have been allocated to for these cities, selected cities. You can see 7 cities, the names of 7 cities on the table, where you have seen that this table shows that there are almost 3,000 crores that have been already approved. And the first installment has been released for almost 6 cities. So why are we not? So the government projects are there. We have the funding under the 15th Finance Commission. So what is there which is actually not allowing us to solve these problems? So for this, we have actually discussion on these three aspects. the rainfall epochs, what is in store for us in the coming years. We have to see that. The gaps in the urban planning, we have an excellent case study from Ghana. And also, we are also talking about the nature-based solution, which will help us in sorting out these problems in the urban areas. Now we have three speakers, Dr. Madhavan Nair Rajivan, who is the current Vice Chancellor of Accra University in Bengaluru and was former Secretary of Ministry of Earth Sciences. Then we have Dr. Stephen Apiataki, who is a Senior Lecturer from the University of Ghana, and the nature-based solution, which is a main part of this whole session, not only talking about gaps and challenges, but also talking about the solution. We have Mr. Yu, who is a lead irrigation engineer from World Bank, and who will be talking on that. So one by one, we will be actually taking in the experts to tell us all the aspects of this urban flooding. But before that, I will request my colleague Sukanya to start the first poll. We'll have small polls in between so that we understand where we stand and our understanding on the whole issue. So, Sukanya, yeah. So 1 minute we'll give for people to actually do this poll. And after 1 minute, my colleague will actually switch this off. So Sukanya, you can, I think if 1 minute is over, you can switch this off. Okay. Thank you, Sukanya. So this is a result which shows that 90% of people feel that the erratic rainfall is affecting their livelihood, and 66% feel that number of rainy days have reduced. So, okay. So we will have Dr. Rajivan Madhavan Nair to actually talk about the whole issue of the climate change in the rainfall pattern, how the number of rainy days are reduced, so that we understand more about that. And as I told you, he was a former Secretary, Ministry of Earth Sciences, with 38 years of experience in weather and climate services. So I will request my colleague, Mr. Vivek Shah, to actually post the detailed bio CV on the chat box so that people also know more about Dr. Rajivan. In the meanwhile, Dr. Rajivan, may I request you to actually project your presentation?
Yeah, good afternoon. Good afternoon to all of you. So can you see this presentation?
Yes, we can see.
Yeah, very good, very good. So I'll be next 15 minutes, 12 to 15 minutes, I will be talking about general aspects of urban floods. And as you know, urban flood is one of the most frequent destructive natural hazards which cause massive socio-economic losses. And also its a magnitude is expected to amplify with urbanization process and also future climate change posing a lot of threats. Causes of urban floods is all of us know that there are natural factors and as well as there are human-induced factors. Natural factors are basically heavy rainfall or extreme weather, intense and short duration drainage system and poor drainage systems, and river overflow of nearby rivers during heavy rains, and coastal cities face flooding from cyclone and sea level rise, etc. These are all natural factors. Human-induced factors are unplanned urbanization, rapid growth of cities without proper planning, and encroaching floodplains and wetlands, loss of natural drainage, basically encroachments on lakes, ponds, etc., increase in impervious surfaces like roads and pavements and buildings, inadequate drainage infrastructure, outdated, clogged, or poorly maintained drainage systems, solid waste mismanagement, and encroachment of water bodies. These are all human-induced factors. It's depending upon which city you are. These human-induced factors may vary from place to place. And first I'll talk about because the heavy rainfall which occurs in urban city is main cause. Flood means water. Water has to come from sky. It's rainwater. Rainwater comes down and it flows, so that is causing flooding. And so we are more worried about what the rainfall characteristics which is now changing. And this is the pictorial diagram which clearly shows that these are the extreme heavy precipitation events, more than 15 centimeter per day, are increasing. You can see that most of central India and western coast, and also to some extent to northeast, the frequency of heavy precipitation events is increasing. More than 15 centimeter. So it's a very well established results which we have. And I will ask a very interesting question. Do you know how many hours it rains in your city? Many of us doesn't know. As all of us know that in all 365 days, it doesn't rain. It rains only few days. And when it rains on a few days, also we don't know. We are sure that it doesn't rain all 24 hours. It rains in few hours. So how many hours it rains in your city? So this is the left-hand side figure very clearly shows that number of total hours in, of course, during June to September. You can see along the west coast is around 400, 500 hours, but along the central India as well as northwest India and is hardly 100, 120 hours. So 122 days multiplied by 24 hours, it rains only 100, 120, 50 hours for the whole season. So whatever rainfall, accumulated rainfall we are talking about, it comes from very small hours. A right-hand figure very clearly shows that cumulative rainfall. One minute. Yeah, the cumulative rainfall, rain hours as well as cumulative rain amount. And it's a beautiful curve which very clearly shows that 50% of rainfall in a particular is for Bombay. It comes in just 25% of total rainfall, total rain hours. Very inefficient. So that means half of seasonal rainfall over Bombay, it occurs only 25% of rain hours. So and 80% is almost 50% of rain hours. So most of the rainfall occurs in a very short period. That is very important. The cities like Bombay, Chennai, everything, that is this characteristics we should know. I'll tell you, many of us doesn't know, that this is the rainfall characteristics of hourly, sub-daily rainfall characteristics, which is very important, causing urban floods. When you talk about urban floods or flooding, we talk about cumulative rainfall for 24 hours, which for urban flood, this is meaningless. We need to really calculate sub-daily rainfall characteristics and study. And this is the one study which we recently published with my co-authors, that even that the percentage of hours in which we get 50% rainfall or 80% rainfall also is getting reduced in many places. I mean, earlier days only maybe 20 hours it is required for 50% rainfall. Now that 50% rainfall comes in 17 hours or 18 hours. So that is the meaning. I mean, in a short period, you get more and more heavy precipitation, which is very important for all of us. Question is why it is occurring. It's mainly attributed to global warming, increase in greenhouse gases, and blah, blah. So it's all well proven. And also this is another study by IIT Bombay group. They say that different places, urban percentage, how much percentage of urban areas increasing in terms of flood level threat. And you can see that at western zone as well as the central zone and northeastern zone, in the later period, the percentage of increase is much more than the percentage of decreasing threat. So there is a general perception, general idea saying that more and more cities are under threat for flood and urban flood, and also within the cities, the heavy rainfall flooding is not constrained within the city, it also expands to the neighboring area surrounding urban city. So that is very important to say. And the study of World Bank report very clearly shows that the people exposed to the highest flood hazard level increased by almost 122%. That's very high. And most of developing countries are driving the recent growth of flood threat at 36,500 square kilometer settlements. And that is very important to say. So in comparison, recent growth in high-income countries is relatively slow and safe. So they are doing much more precautions to control the flood levels. Whereas this results, therefore, this results document evidence of countries exposure to flood hazards. So many low-income countries, rather than adopting their exposure to climate hazards, many countries are actively increasing their exposure to urban floods. This is the way how an urban city is expanding. This is a beautiful land use cover map of Adayar Basin in Chennai. You can see that pink color is all urban area. You can see that left-hand side was 2002 and right-hand side is 2015 or so. So you can see that how much area is increased in Adayar River Basin. And also this is a beautiful landscape, the satellite observations of Hyderabad expansion, how Hyderabad city has expanded. 1990, 1999 and 2040, exponential increase in urban area. And I'll mention about two floods. One is 2015 Chennai floods, and you must have, I remember that's just after the 2015 Chennai floods, I took over as the Ministry of Earth Sciences, December 7. So that was the visit to Chennai was the first official visit after I took over as secretary. I still remember the casualties and damages caused in Chennai city. It was the worst flood in 100 years, 1,200 millimeter rain. And so there are possible reasons for that kind of flood in Chennai. So some people say it's a wetland encroachments, over 300 wetlands and lakes were filled for expansion, especially in Velachery, Pellikarnai marshlands. Inadequate drainage systems they had, poor maintenance of storm and all garbage, still blocking channels, blocking channels, and reservoir release of water from reservoir. It's very controversial topic. But many hydrologists now say that that was one of the reasons for the severe flooding in Chennai and unregulated construction. So this is not only related to Chennai, it happens in all cities nowadays. And Bengaluru, September 2022, the major parts of IT corridor were submerged after heavy rainfall, and very frequent localized rainfall happened. And there are many reasons for why it happened. One is loss of lakes. Then stormwater drains were problem. Encroachments on drainage paths also was one of the reasons. And episode urbanization, we need development, but then it should be very well planned development, and especially new developing tech areas. And topography and poor drainage. Bengaluru is very highly, topography is highly heterogeneous. It's a hill. It's 1,500 meters or so. It's a hill. So there's a lot of heterogeneous topography. So we need to be very, very careful. As I said, that the main cause for flood is water, rainwater, coming from sky. Is the water. Water is nothing but a fluid. The fluid has to flow. The fluid, how we define a fluid is it has to flow. So if the rainwater comes in a very short period of rain, in few hours, 10 centimeter rains, if it cannot really flow out to, for example, sea or river, it will go up. The river, the water level will go up. That's simply flooding. So even if it rains very heavily, if there are systems in which the water can really flow out of the city, then the urban flooding will not happen. But that is not happening. So, of course, the frequency of this intense precipitation events is increasing, but that is not the only cause for urban floods. The urban floods is even if it rains, if the city is well equipped to drain out that rainwater in a few hours, then we can really avoid the urban flooding. And this is a beautiful study published by about 3 years back, how the urban exposure to flooding in 2018, the top one, and change in magnitude during last few years. You can see that everything is positive, and over the Indian region, it is almost 45% of change of magnitude in kilometers square per year. So it's a very big number. And right-hand side shows that the yellow is all for Asian countries. We can see that the UEF, urban exposure to flooding, is increased substantially for last many years. And the more problem, severe problem exists in Asian countries. This is another study, fraction of urbanization. This also shows the same result. There's a map of urbanization, present fraction for 2015 for 100-year floodplain in the top, and how it has changed after 85. You can see that the most of the expansion taken place after 1985. So this is very clear that urban cities are expanding. Urban areas are expanding, and without any formal thinking. And so we have, so question is whether this rainfall coming from sky can be, and the flood level can be really predicted. And so we have developed, when I was there as a secretary, we have developed a system. Of course, we had developed earlier for Chennai, then second, we developed for Mumbai. It was developed by our institute at Chennai and National Center for Coastal Research in collaboration with the Mumbai Municipal Corporation. So it's a very highly sophisticated, very dynamic, very mathematical model. It's including data assimilation module, flood module, inundation module, vulnerability, risk modules, and finally dissemination. So very good forecasting, early warning system for flood is called iFlows. And these are the components of different components for, we have forecast for 24, 72 hours forecast we get from IMD's models. Then also we have forecast for next few hours, then put it into the models, etc. And then we finally give an alert. And so what we need for flood warning is very dense observation, rainfall observations. Theoretically, WMO prescribes that every 1 kilometer you need 1 observations. We don't have. So we are, during my time, I remember we have put almost 150, 200 rain gauges over the Bombay city, but I felt it is not sufficient. So what we decided is we will put radars, which can be used to measure rainfall. So we are installed now, so IIT Pune, the ministry is funding, they installed 4 radars. But these radars are not very big radars. It's only, you can see only 60 kilometers. So if you put 4 radars at 4 different corners of Bombay city, it can literally see the whole city. And then the radar can be used to measure rainfall every 1 kilometer, even 500 meters. And also every 15 minutes you can repeat it. So it's a very highly localized information we can get it. And hopefully this is going to be put operational this year. And because of COVID, there was a lot of delay. So 2 years, 2.5 years, it was delayed. But this observation, radar observation along with the rain gauges will give you plenty of observations and very hyper-local level, which can be used for flood routing, flood water routing, etc. And the question is how good the models are predicting heavy rainfall. Very quick answer is no, it's not really good. So I should confess it. The models do have tendency of predicting more of lighter rainfall in the model when model is used. But when it comes for predicting a heavier precipitation, it is really not really good. So it tend to predict more and more of lighter rainfall, but it tend to predict less and less heavy precipitation. So that's a very serious concern for all of us. And this is a verification which I got it made when we introduced the so-called the Bombay iFlows flood warning system. The basic input for this flood warning system is how much rainfall is going to occur for next 12 hours or for 24 hours, and got it verified. It's not really pretty good. So there are a lot of concerns for this is all very high resolution model, 4-kilometer model, but then the verification doesn't really is encouraging, at least to me. And IMD also, you may be knowing that they are issuing heavy rainfall the flood warnings for river basins, different river basins. And when we really did the analysis of how good that those river warnings is called, we call quantitative precipitation forecast, which can go into river routing and also the flood level estimation, etc. And that forecast also not really pretty good. So beyond two days, the forecasts are not really pretty good. So up to 2 days, it's okay, reasonable. But for a real valuable flood warning system, you need forecast even 3 days before, 4 days before. So issues related to urban flood management, basically it's poor urban planning and governance, outdated drainage system, fragmented institutional responsibility, data gaps and monitoring deficiencies, weak early warning system. This is what just now I mentioned about our early warning system is not really robust. I should confess it. And we need a lot of work to be done on improving this. I'm not saying that it's hopeless, but I want to say that there's a lot of scope for improvement of the early warning systems. And climate change is neglected in planning. So when we make a development plan, we don't see how the climate is going to be after 20 years, 30 years. What we have now is the drainage system. Everything is for 50 years back. The drainage system is not really good, or the planning is not good even for the present day. Forget about future. So when we really develop for any planning, any development plan, we should really think about not only present, but also the future, at least for 15, 20 years, even 30 years, 40 years. We have a good climate models which can give you some fair idea how the climate will be in after 20 years or 30 years. So that we should do. We are not really doing it. Then, of course, public awareness and participation. And this is probably the last slide, which says identify drivers for urban flood risk. And you can see that some impact as well as manageability. Impact may be low, but impact may be high, whether we can really manage. And so you can see that climate change has high impact and manageability is very low. We cannot really control climate change. It's a huge complex phenomenon. And increasing complexity of society is high impact, but there also is very difficult to manage it. Whereas public awareness, individual willingness and all is manageable, manageability is high, but the impact is not that good, moderate. Decreasing permeability is a possible thing. The impact is high, and also the manageability is also high. Increasingly unresponsive engineering, we can control it. So some of the things which we can really do, so which we should really plan and do these actions. So way forward is we need a very integrated. We should have an integrated urban flood management plan with land use, etc., and retention ponds, etc. Restoration of natural drainage we should do as much as possible. Strengthening of drainage system we should do. Use of technology, real-time data, advanced urban flood warning system. Institutional reforms we should do. Better coordination between agencies. X should not say it's not my work, it's the work of Y. Y should not say it's not my work, it's the work of X. So this kind of, so there should be a lot of good coordination and climate resilience. That's most important. We are not talking about anything. We are not talking about a flood warning system without climate change. So that is very important aspect. So thank you very much.
Thank you, sir, for this excellent presentation. So many things we did not know about the flood warning systems, because we have some of the questions also related to this. So we'll come back to the question answer hour, which is after all the three presentations. So can I request my colleague Sukanya to start the second poll, because before going to the second speaker. And it will be for a minute only. So Sukanya, you can, okay. So everybody, more than 80% of people think that loss of green areas, built over water bodies, polluted water bodies, all these things are actually a reason for the urban floods. That's great. And root cause of urban flooding, according to many, is that under designed stormwater drains, rainfall variation, loss of water bodies, and rampant urbanization. So that's great. So everyone, more than 70% of us actually, of the audience, feel that the root cause of urban flooding is all of these factors. So thank you very much, and we'll go to the second speaker, Dr. Tyaki, Dr. Stephen Apia Taki, who is a senior lecturer from the Department of Planning, KNUST, Ghana, and he has over 17 years experience in planning, and he will give us a case example from Ghana, how the gaps in urban planning actually is causing frequent floods in Ghana. So over to you, Dr. Taki, if you can take over.
Thank you, Susmita. I hope you can hear me clearly.
Yeah, we can hear you and see your slides as well.
Thank you very much. I think Professor did a good job by trying to give us a background. Let me first highlight that his observation from the Indian perspective is not really different from the Ghanaian perspective. So you see that there are a lot of things that he's already shared that may be similar. Let me start with this position before I introduce my outline to the audience. Let's reflect on this. If it does not rain, we call it drought. If it rains, it becomes a problem. What do we really want? Do we want the rains or we do not want the rains? So in this presentation, we look at a brief overview. Then we look at the role of city planning in environmental sustainability and dealing with issues of urban flood. Within the Ghanaian context, we are going to look at what are some of the existing laws. How has urban planning failed to respond to these issues? Then we give some situational analysis of urban flooding in Ghana. Then the way forward, then I can conclude. Since I have about 50 minutes for this presentation, so most of the issues will be left for the questions. So as I started, as we speak now, global South countries and cities are confronted with the issue of climate change. If it doesn't rain, cities are faced with drought, extreme drought conditions. Farmers cannot farm. If it rains, we are confronted with flooding. But for my philosophical and positionality as a researcher, I believe in one thing, that it takes efficient engineering, effective planning to take advantages of the blessings of rainfall. So in my position, I think that rainfall is a blessing, unless it's a natural disaster. So we have natural disasters, as my senior colleague highlighted, but if it's not a natural disaster and it's a normal rainfall, then it's a blessing that must be managed in such a way that the cities do not flood. Therefore, you could see that Gilbert White notes that floods are acts of God, but flood impacts are largely acts of man. So the flood could be a natural disaster. However, city planning is a system that will help to shape urban planning resilience and take the advantages of rainfall to the development of our states. Now let's look at the role of planning in an urban system. I normally, in such lectures, say that urban planning is not only for urban planners, but it's for everybody. So we say that urban planning is a multidisciplinary concept that involves engineers, all activists, and it's in the interest of the nation, the city, for us to plan. So why do we need urban planning? To make sure that we are the land that we are using are being used efficiently. We make sure that it's promoting, making sure that human beings coexist with nature. We make sure that our livelihoods are protected. We make sure that urban planning promotes our economic growth whilst promoting our social growth. Where will we play? Where will we have leisure? So urban planning is not for only planners. It's for everybody, and it's for anybody, and it's for everybody in the human system. Urban planning major core is our zoning regulation. Let me highlight here that planning cannot work in cities and countries where laws are not enforced, because the planning system goes with laws. Therefore, if you have your zones, which shows where you should locate a particular land use, and that is not enforced, that becomes a problem, and planning begins to fail when laws are not enforced. Also, here I think my engineers will look at it. Every city need a drainage and stormwater plan, its infrastructure plan, its environmental services. One major issues with countries in the global south is that in terms of investment, in terms of focus in the planning system, we tend to neglect the environmental service. And that's why I started that rainfall is a blessing. So it is true environmental service that will make sure that the rains that are coming are stored and linked to agricultural development. So we plan for these things and link urban planning to engineering to make sure that what is becoming a curse actually becomes a potential. Urban plan also look at the environmental impact of human activities. Then we mitigate and minimize its effect. So that is the role of urban planning. But against all these things, the planner can zone areas. The planner can manage land uses only if it's backed by the enforcement of laws. One of the major issues that I need to highlight that in countries in global south, our appreciation of urban planning, our love for urban planning, our ability to even support planning institutions to work is very limited. And even the enforcement of planning regulation is limited, and we'll go there very soon. And that is why we are here to discuss most of the issues we are discussing today. Within the context of Ghana, let me highlight this. Ghana does not have a problem with laws. Ghana does not have a problem with planning institutions. Our biggest problem has been the enforcement. So when you look at it, it was a research I did with one of my research assistants, Lowe, and we looked at the regulations that protect buffers in Ghana. One major highlight that we saw that various government agencies have their own regulations. So, for example, the planning institutions, which derives this law from the Land Use and Spatial Planning Authority. The Zoning Act says that we are not supposed to build from 30 feet to 300 feet along the buffer. Interestingly, when you pick agencies like the Forest Service Division, the Ministry of Lands and Forestry, Hydrological Service Delivery, the Ghana Water Company, or Company Limited, you could see that as depicted on slide, all these agencies have their same laws. So different laws. So the same nation, you could see that people have different laws. So in the study, we saw that it may be the same nation, but you can arrest somebody and say you're breaking the law. But that law, if they use the Ghana Water Company law, the person may not have broken the law. And I think this is similar to most countries in developing countries. Instead of institutions working together and see the urban system as a place that we should manage to make it comfortable for national development, every institution based on research expertise have their own laws. So instead of addressing city planning, the management of city from a multidisciplinary perspective, everybody is trying to manage the city from their silo disciplines, and that is contributing to complicity with regards to our laws and regulations. Now, I know that most planners are not comfortable when it comes to the issue on how planning system has failed to address the issue of flooding, but as academics, and experts, we must always confront the truth. I highlighted that Ghana does not have a problem with the laws. We also don't have a problem with, in terms of trained, well-competent human resources. But I also said that the major similarities for developing countries is the fact that we are not committed to planning regulations. We've not committed ourselves to make sure that the regulations are enforced to the latter. So in a study that I worked with one of my master students who later became the Deputy Minister for Natural Resources, we noted that buildings are allowed in waterways, floodplains, and wetlands. So if we do this in contradiction with the zoning regulation, it's not surprising that our cities are flooding. Of course, we have the institutional arrangement, we have the laws, but the capacity support and investment for the planning system is also very limited. That's what I said in the global south. Our commitment to the planning system has been minimal compared to the global north. Maybe they know the jewel for national development if we commit to the planning system. And when I say the planning system, I'm not only even referring to only the planners, but even our engineers in our district assemblies, how we commit ourselves to make sure that the laws work, they have the technical and financial capacity to save our cities. Of course, the system, we also have issues of political interference and land allocation. In fact, Ghana has an interesting land tenure arrangement. I summarize it by saying that it's the traditional leaders, the chiefs who owns the land. Then it's the institutions like the planning office who manages the land. That alone is a conflict. And that in my study with one of my research assistant, who is now gotten a PhD opportunity, we noted that there are, if we like it, on level of political interference and traditional leaders who are also leasing and selling land without regard to the planning laws. And all these things are contributing to the Ghanaian state as it stands now. Now, I wanted to limit sharing our experience to what already exists. I know that the center invited me because of this publication in Conversation Africa. And I want to thank Smith and her team at Center for Science and Environment for the invitation. But in this study, it is coming from a research where the former minister argued that Accra is flooding because of climate change. So we wanted to use the definition of climate change of long-term changes in climatic conditions. In fact, there is a difference between climate change and climate variability, as the experts will tell you. So if there are short-term changes, of course, it's climate variability. So we wanted to test what is happening in Accra. Is what the former minister saying, is it the reality? So we started looking at the rainfall patterns in Accra to check whether there has been any long-term changes in the rainfall pattern in Accra. In fact, the interesting thing we saw was that within a 10-year period, there has not been any major changes in the rainfall pattern in Accra. In fact, there are years that the rainfall pattern dropped, but the flooding rate increased. So it means that the rainfall pattern was dropping, but the rate of flooding was increasing. It means that there was other factors other than climate change that is leading to increase in flooding in Accra. And that is why he hinted on Professor's initial presentation, where he looked at nature and human induced. You could see that in the case of Accra, our research showed that it's basically human induced. And as I highlighted, we have issues with poor and uncoordinated land use. The enforcement is a major issue, and we could see visibly encroachment in wetlands, where urbanization have no regard for natural resource sustainability. In our study supported by the Kenya University Research Fund, Urbanizing Against Ecologically Sensitive Areas, we also saw that in Kumasi, the second largest city in Ghana, also has the same issue like Accra. And when I was listening to Professor's interview, then it means that it's also similar to the Indian situation, where people are building in ecologically sensitive areas as if the law does not exist. So, for example, you could find commercial activities, squatter settlement, and other land uses springing along the Subin River with no recourse to the planning regulations. One of the questions highlighted green spaces, and I love it. What happens if our cities are being built with concrete surfaces? If we are building cities with concrete surfaces without looking at green areas, then we should not be surprised that cities are flooding. So here we looked at what is happening to still the compliance of regulations. And we saw that most planning institutions are basically powerless because they are supposed to enforce the law, but the land is owned by traditional leaders. Politicians can override their efforts, and therefore it's contributing to the non-enforcement of the planning regulations. I was going to look at how urban parks in the second largest cities have been rezoned. So in our study on urban park under siege, the city that used to be called the Garden City of West Africa, because of its environmentally sustainable nature, had 14 out of 16 major parks that have been rezoned into commercial and residential land uses.
Dr.
My dear
Teti,
audience, if you have this scenario,
2-3 minutes
and your
more.
city begins
Dr.
to
Teti,
flood,
if
yes,
you can,
please.
2-3 minutes with.
Thank you.
Okay.
If you have this scenario and your city begins to flood, then it is not surprising. I have other studies that have shown, but what is the situation with regard to flooding in Ghana? I told you that when we talk about flooding, it's not about the urban planner, it's not about the engineer, it's everybody. And when you look at the June 3rd disaster in 2015, Ghana lost 152 people. And the amount of money that we lost was $100 million. It means that the flooding is threatening our investment and everything that we are doing. And it calls for action from everybody. So annually, we are looking at $200 million annual losses. So planning is not only about a few professional planners, or engineering is not about the engineer, it's about saving our own assets through mitigation measures. Now, the way forward, based on what I've said, if we like it or not, our cities will continue to grow. If we like it or not, the rainfall will come. The time has come for city authorities, citizens, urban residents to understand that we can coexist with nature by making sure that we all dedicate ourselves to the enforcement of planning regulations. So, for example, I did my master's in Canada, and one thing I saw about the Canadians is that they themselves understand that the planning laws and the system is about them. So they are involved in protecting their natural assets and their cities. So they have environmental citizens who help planning authorities to enforce the land and the laws. So one of the areas is to make sure that we have environmental citizens who will help planning authorities to ensure the enforcement of planning regulations. Also, there is the need for countries in global south to start adopting emerging concepts such as the polluter must pay principle. If we do not enforce the regulations, we are going to pay the cost of the destruction of nature. Therefore, those who are polluting our cities, those who are destroying, they must pay. Then we use it to fund the expensive environmental service that we need. So we need both a planning solution and engineering solution. But all of them goes back to money. And we need the polluter must pay principle to fund how we can save our cities. In fact, we have to upgrade and maintain our drainage system, as Professor highlighted. As I conclude, I told you it's a 15 minutes lecture, but as I conclude, planning, urban planning, is not only about the urban planner. The urban planner is only a tool to ensure that people coexist with nature, the economy, and social systems. The citizens in the global south must start appreciating the role in urban planning in solving our current flooding crisis. In as much as there is climate change, we cannot forget that the issue of flooding is being aggravated by our actions towards nature in our cities. And the only way urban planning can help solve us is when we support to hold our urban planners accountable, support to make sure that the urban planning in our democratic system are supported and equipped, and to make sure that we ourselves are citizen planners to ensure that whatever the planner has demarcated, we make sure it is enforced to protect nature and make sure that we coexist with nature. Thank you very much.
Thank you, Dr. Tyaki. That was excellent because you have given the economic loss, which actually pinches us, which tells us that, see, this much we are actually facing the loss in this way, and these are the economic loss. So everything counts to money, and then we can understand like what are the problems and where do we need to find the solution. So we will have the third presentation, but before that, we'll have a poll. I'll request my colleague Sukanya to yeah, thank you. So you have 1 minute for this poll, and please quickly do it so that we can start with our presentation. I have much time for the question answer session also. Great. So we have a solution for mitigating urban floods, where people think that management of waste, drain network, desilting, green space, rejuvenating, everything counts. And the maximum number marks is for, I think, the proper management of waste. And then the second question, traditional lakes, people think that more than 75% people think that traditional revival of traditional tanks will be helpful. So thank you for your poll answers. And then maybe we will start with the third presentation, which is the way forward, and which is the most important session, which will be by Mr. Yup Stoutier Dyke, and he is from World Bank with over 42 years experience in the area of irrigation, drainage, flood management, and he specializes in irrigation irrigation and drainage, and he is a civil engineer by training. So we are projecting your presentation, Mr. Yu, and you can tell us when to change the slide.
Okay, thank you. Good afternoon, good morning, good evening, wherever you are. And I think the poll gave the right answer. Many of these issues are very important, and I'll talk a few minutes about that. I know we're running out of time, so I'll try to be quick. So I'll talk about nature-based solutions and a little bit more in general about retention capacity to mitigate urban flooding. Next slide, please. Next. Yeah, so this is my outline. I will not, let's go there, yes. Yeah. So Dr. Nair already mentioned many of the same issues. What are the causes of urban flooding? I'll just point at a few points. So many of these large cities in the world are located in low-lying areas near the mouth of the river, where the mouth of the river enters the coast. It was very convenient, of course, but it also means that you have a very large upstream catchments that overwhelm urban areas with floodwaters. In most cities, Chennai was mentioned, but Bangalore, of course, is a different issue. And really, there should be no flooding in Bangalore. Bangalore is on a ridge, and the water should naturally drain out. Yet it suffers suffer for flooding many times. Then rapid unplanned urbanization has been mentioned, so I will not go in detail. Lack of supporting infrastructure. We're always a few steps behind with infrastructure. Informal settlements. I work a lot in Metro Manila. 3 million informal settlers live in the city out of 50 million. That is 1 in 5. And many of them live in the floodplains because that's where no one else lives and that's where there is space. Dr. Nair also mentioned outdated infrastructure, siltation, solid waste has been mentioned, and the whole issue of climate change, which was discussed in the first presentation. So let's go to the next slide, please. The two previous speakers talked about human factors. Yeah, that is really the problem, right? We do poor planning, poor execution, we have little respect for nature, and as Stephen mentioned many times, weak enforcement or no enforcement whatsoever. So that catchment degradation, siltation as a result, solid waste, big issues in most big cities. So yeah, so humans are really the main cause of many of these flood issues. Next slide, please. Next slide. Can you move? Yes, thank you. So now, what do we have as typical responses? So no, go back 2 slides back. 1 slide back, I think. One more back. Right. No. Okay. Yeah. So yeah, there's no one size that fits all solutions. Many cities have unique challenges. As I mentioned, Chennai and Bangalore, they have different challenges. But wherever we are, many public works and other related agencies, they really focus on great solutions. After all, engineers like to build. So a lot of emphasis is put on stormwater drains. We're starting a program in Bangalore now, and all the stormwater drains will be lined with concrete, which is important because you need there's little space to expand these drains, so you want to make sure that as much floodwater as possible can be discharged. And lining, of course, help to increase the discharge capacity. Next slide, please. Next. All right. Oftentimes we do forget about the smaller drains. No, one back. About the smaller drains, they should be well incorporated into the design. So there's the street drains, and then there's the larger the drains to take water out of the streets into the stormwater drains. So it's very important that there's an integrated approach, integrated design and construction approach. Not always done. Many cities don't have proper street drainage or proper lower level drains. Now, one other issue which comes up in many places, that these stormwater drains, they're designed based on historical rainfall. And Dr. Nair had a whole presentation on rainfall. But of course, their function will be impacted by climate change. So a 1 in 10-year rainfall event will become a 1 in 8-year rainfall event. You mentioned in one of the polls that the number of rainfall days goes down, but the intensity often increases. Some water drains will often not be enough anymore. So while the impact is important, but it will be limited, and it will become more limited over time. Next slide. And this is really where the increase in retention capacity becomes important. Nature-based solutions are part of that. You need to look in these cities what are the possibilities to increase the retention capacity. So I do agree with the topic of this webinar, that nature-based solutions are crucial in mitigating flooding in urban areas. You need to increase the water absorption, you need to reduce the surface runoff, or to allow the reduction in the surface runoff, and improve the urban resilience. Now, nature-based solutions should not be designed independently. They are part of an integrated system approach that enhances floodwater retention. And it is there to augment and complement the grey infrastructure, the stormwater drains, as I said earlier, because over time that capacity will reduce. Now, very important is that every city should start with mapping to identify the vulnerable areas, because many places in the city will have little flood impact. So you need to move to the places where the biggest impact is. So that's where you then have to focus on your solutions, so that you actually can prioritize certain areas in the city where you should work. So next slide. So in the World Bank, we focus now. No, go back one slide back. Okay, yeah. So no, please go one slide back. Yes. So in many bank projects,
Actually, it is working automatic, actually.
Okay. Can no one stop that? Oh, there we go. Okay. All right. So just some quick examples then. Restoring the lakes has been mentioned already, very important. In Bangalore, I mean, Stephen talked about lakes and wetlands are disappearing. Same, for instance, in Bangalore. Bangalore, a big bus terminal is now, yeah. So we are going too fast here. I don't know why you can't control that manually, but
it's automatic, going automatic. We cannot control it.
Okay, I don't know. Anyway, let me give some examples of nature-based solution. Restore the lakes, which also has been mentioned in previous presentation. We're doing this in Bangalore at the moment, but because many of lakes have been lost and they will not come back, but the lakes that are there should be restored and should become part of an integrated flood management program. Utilize green spaces. Again, for instance, a city in Bangalore has lots of green spaces. Utilize it to retain the water. You can create artificial wetlands, retention ponds, and also do rainwater harvesting. Native trees and vegetation are important. Replace concrete surfaces, permeable pavements, and green roofs, also mentioned by Dr. Ryan. Large-scale rainwater harvesting, for instance, Singapore, every large building has now green roofs and also has rainwater harvesting. In many of these wetlands, you can construct recharge wells so that you enhance the groundwater and also reduce flooding. And then utilize parks and parking garages for temporary retaining of water. For instance, in the Netherlands, we use playgrounds, we use parking lots. Once every 20 years, we allow an underground parking lot to be flooded, and when the floods are gone, when the rivers are back in normal capacity, then you release the water. Now, finally, I did mention the last slide here. Nature-based solutions are important, but they are part of an integrated solution. Flood retention. For instance, in Metro Manila, we are constructing a large dam upstream of the city to keep water out of the city during typhoon events. When the floods in the urban areas have receded, you can release water out of the dam to create capacity again for the next floods. Room for the river. We do this in the Netherlands. We basically allow the river to flood certain areas, agricultural land, every 10-20 years to ensure that the big cities further downstream are not impacted. So this is all based on a risk-based approach now. And finally, in addition to reduce flooding, benefits of nature-based solution and retention capacity also include improved water quality, increased biodiversity, and even cooler urban temperatures, as we have found out. So in a way, nature-based solutions are good for everyone who lives in the city, and people can benefit not just from the flooding impacts, but also from additional benefits of that make living in the city more comfortable. So thank you very much. I'll stop here for the sake of time. Thank you.
Thank you, Mr. Yup. So that was an excellent presentation, which actually talked about the blue-green features in the cities and how it should be used to tackle the floods in the city. Now, we have 5-7 minutes, and we already have some questions which were actually asked before the sessions. So I will take up one after another. So the first question is to Dr. Rajivan. This is from Ashini Seth, a researcher from Netherlands. And how does IMD issue flood warnings? Are there warnings based on certain rainfall parameters or based on impact? Over to you, Dr. Rajivan.
Yeah, so IMD does the flood warnings for river basins separately and for urban floods separately. They use physical models, mathematical, numerical weather prediction models to calculate quantitative precipitation forecasts, and then they give it to Central Water Commission. Then they calculate the flood level, etc. For urban flooding, I think they use very high resolution models with a lot of hydrological inputs, and also how the rainwater will flow into the city. The city's topography, drainage system, and everything is modeled into the model, put into the model. So it's based on just only one parameter. It is based on different parameters included in the physical models. So they use very high resolution models for flood warnings.
Okay, thank you, sir. So the next question is for Dr. Tyaki. So, we have Rakesh KN, a government official from Kerala, who says that one of the main reasons for urban flooding is clogging or blocking the stormwater drains. And this blocking often occurs by dumping the waste into the stormwater drains. And to address this issue, the basic requirements are sensitizing the public and the officials, comprehensive and integrated approach for solid waste management and liquid waste management, stormwater management, flood controls, etc. So, what are the effective ways to address this? Is there any initiative or policy development towards this? I know you have touched many points in your presentation, but if you can answer to him.
Thank you very much. And I think that is a good question, and it's one of the questions that the questioner actually offered solutions. So in the question, you see that he or she highlighted sensitization and integrated approach to waste management. But one of the issues, if you listen to my presentation, I highlighted that most of the time, urban planners and engineers don't look at the financial bits. And that's where policymakers are skeptical. So in Ghana, there was an introduction of the excise duty on plastics that was supposed to be used to build recycling plants. So the polluter must pay principle offers a sustainable funding option. Once you have the sustainable option, then you can look at how do you make sure that you segregate and separate the waste, because now waste is actually a resource, not a waste, and it can create employment. So once you're able to segregate and separate and recycle, then the issue is being dealt with. But you can only do this, as the questioner highlighted, through an integrated approach. If the city residents have not been educated to segregate their waste, they can't do it. If we don't also have the money to provide the requisite infrastructure to support the segregation of waste, we cannot do it. So in the Ghanaian context, one of the most good examples was the taxes on plastic waste, which was supposed to be invested into recycling and other things. Now, I don't think we've invested in it, but it's a good case to provide sustainable funding option for the recommendations he like. Then we can look at environmental literacy program. In the global south, in our educational curriculum, educating our citizens on environmental literacy has not been very prevalent. So how do we manage our waste? How do we dispose it? Do we even value waste that can be recycled and reused? So it means that, as he highlighted, it should not just be sensitization, but in our educational system, we should have programs that will promote environmental literacy. Once the population are educated, most of the issues raised by my senior colleagues in there will be dealt with. So thanks to the questioner, and I agree with the integrated approach that he highlighted, including the funding sources for waste management. Thank you.
Thank you, Dr. Tyaki. So we have one question for Mr. Yup. So this is Ashwini Pai, who is a consultant from India. And he's asking, how can the performance of the nature-based solution in reducing flood rates be measured and monitored over time?
Yeah, no, thanks for the question. Good question. So whatever developments you do, there will always be flooding. Now, flooding impacts everyone, but flooding in a way impacts the poor the most, because many of the poor, they work on the streets. You go to Dhaka, the rickshaw people and others, people sell on the street, so it impacts them. Now, in the World Bank, we try to reduce poverty and the thing. So we are very much focused on the poor. So even though it is accepted that there will be flooding, the impact, the way we often measure the impact of intervention is the time needed to have the flood water receded from the streets and from other populated areas. So if it's, for instance, in Manila, we have a project. It may take 2-3 days for at the moment. After the intervention were done, it took 8 hours for the water to recede. So within 1 day, people can go back to normal life and they can continue their activities. So that's how we typically, as an indicator, measure the impact of the interventions done to reduce the flooding. So you can never claim there will be no flooding, but the sooner your water is gone, the better it is for everyone. So that's how we typically monitor and measure the impact.
Okay, there's another question for you from Mr. Sandeepan Chaudhary. The problem in Indian cities is lack of space. So increasing storm frequency, even 2 years, is a big problem. Most roads are 2 to 3 meter wide in class 1 cities. In such situation, what is the solution? Isn't it better to cover 100% rather than going for higher storm frequency and wider drains?
Yes, so that is indeed. I mean, I work in Bangalore now, and it's a 1 in 5. They try to do a 1 in 5 year return period. So in a way, every city is different again. But it sort of links to my previous point, right? You cannot have zero flooding, uh, but you need to try to reduce the impact as quickly as possible. So you need an integrated system, not just as I mentioned, the gray infrastructure, but you need to have as many solutions as possible. And over time, these solutions will also increase. Um, we may not need a lot of nature-based solution to start with in certain areas, but over time you need to make sure that also because of climate change you increase the capacity to retain water. And this is what I mentioned in my presentation. Very important is to do the mapping exercise. So you actually focus on the areas that needs most attention, and that's where you come with your integrated solution as soon as possible.
Okay, thank you. And the next question is for Dr. Rajivan. Sir, this question is very interesting. What minimum spatial density and telemetry specification of low-cost ultrasonic depth sensors, weather radars, and crowdsourced alert nodes would satisfy World Meteorological Organization Category 2 standards for an integrated urban flood early warning systems in data sparse Indian coastal cities? And how can edge computing AI classifiers be incorporated to filter false positives in citizen-generated flood reports? A long question, but very
Yeah. So it's a long question, but I will try to answer. And so it all depends on which urban city you are concentrating, and which if it is only for flood warning system, the specification is every 1 kilometer you need one rain gauges. Every 1 kilometer you need one rain gauges, and every 10 to 12, 20 square kilometer you need one surface observatory which measures temperature, humidity, that kind of thing. And then you need additional weather radars of basically 250 meter to 1 kilometer resolution to get rainfall up to 250 to 1 kilometer. This is what exactly we done in Bombay. We don't have rain gauges in that 1 kilometer sense, but we have weather radar in that 250 to 1 kilometer grid size. And surface observatories also we don't have 15 to 20 kilometer square area. So these are the specifications. Then you need additional water level gauges, urban drainage monitoring systems, other sensors, inundation, etc. So it's a very highly complicated network. So the WMO prescribes for the urban cities. We cannot go ahead with the normal observational network which is prescribed for weather and climate services. For urban cities, we need much more dense network, and this all depends on how the city is and what you want to address it. And the second question regarding AI, definitely artificial intelligence will play a role to improve the flood warning system which we are now making it. I fully agree with you that we should not give a false alarm, and also we should pick up the right flood warning events. So that's flood events. So AI and ML will definitely play an important role. So I'll stop here.
Thank you, sir. And the last question to Dr. Tyaki. Just a minute, I'll just say. We are thinking about what is your experience of high performance pervious concrete for roads, pathways, and parking lots in urban areas?
That's a good question. And from the planning perspective, if we like it or not, those roads and concrete surface are supposed to be developed. However, in the Ghanaian context, in the planning regulation, there's a percentage of concrete surface. When you pick your own house, there's a percentage of concrete surface to green areas that you are supposed to build. In the design of roads, that is not very popular in Ghana, but because the roads actually involve concrete surfaces and high performance asphalt, and it doesn't allow penetration, we are supposed to design roads in such a way that there are green areas along the major areas or the central veg. So if we like it or not, we need roads. If we like it or not, there are some areas we need concrete surfaces, but we are supposed to balance it with green areas. So when we are building our concrete surfaces, we should ask ourselves, where will the storm water go? And I agree with the previous speakers too that as we look at the green areas too, we should also look at stormwater management ponds and areas to store our rainwater. So, for example, in our homes, how many homes in the global south do rainwater harvesting? It's not something we are very popular in doing. But water is expensive. It's also money. Once again, the finances. So apart from the concrete surface, when you build your home, should it be only concrete? The land use regulation says there should be a percentage of green areas in your home. And that is a planning regulation. Once again, the enforcement. Then in terms of the design of the road, it should not only be the asphalt, but it should also coexist with green areas. Trust me, it makes the cities even nicer, apart from the environmental benefits. And let me support one argument that a commenter made, that we do not need effective waste management only to manage floods. We need it for our cities. So it's not only flood that we need to manage effective waste management. Also, we do not need green areas only to manage flood. The city must be healthy. So along the road, we need the trees, we need the green grass to manage flood and make the city healthy. So we should combine it. If we like it or not, the roads will be constructed, but we should combine it. That's what we call it, design with nature. So you construct it, but you think, where will the water surfaces go? There was when we went for field in Canada, there was a design that I love so much. The drains was not concrete. The drain was green grass. So they dug the hole and planted green grass. And it was 7 double purpose, managing flood water, green spaces, and other things. So I would say let's balance it. But there are certain things it's inevitable. My engineers will tell you. We need the roots and we need the green areas. So it's about balancing it to coexist. So it's about designing with nature so that we balance it. Thank you.
Thank you, Dr. Techie. So we have a huge number of questions, and also, people have really liked all the sessions, and there are some more questions which we can take up later on. I'm just requesting the audience to keep some patience, and maybe you can send the questions to us, and we can actually get back to the experts and answer these questions later on. But right now we are running short of time. So let me thank everyone to be part of this because we had some excellent discussion, and thank you for being part of this whole session. Thank you, experts. And as you see, there are huge appreciation on the chat box for all the experts. And I thank you again for actually joining in for this excellent discussion. And so we can actually come back to you if there are some very pressing questions. And thank you very much. And we can join again later on, connect with each other on these issues. Thank you.
Thank you.
Thank you, everyone.